All right, let's pull back the curtain on the incredible, surprisingly high-tech world of modern textiles.
I mean, it's a question most of us probably don't think about too much, right? But the answer? Well, it's getting more and more surprising every single day.
Believe it or not, the story of that vibrant spool of thread on the right often begins with what you see on the left, a pile of old plastic bottles. It's this incredible journey from trash to treasure, and it's all powered by some seriously advanced tech.
So, how in the world does that actually happen? Well, it all starts with the raw material. Okay, so you've got companies like SSR Polyplast who are really leading the charge here. They take all this non-biodegradable PET plastic, and PET is just the fancy term for polyethylene terephthalate, you know, the stuff your soda bottles are made of, and they start processing it. The very first step, they shred it all down into these tiny, colorful flakes. This is literally stage one of its brand new life as fabric.
The whole process is this amazing mix of chemistry and engineering. You collect the plastic, you shred it, wash it, and then melt it down. Then, and this is the cool part, it gets pushed or extruded through these super tiny holes to create something called polyester staple fiber. That fiber is what finally gets spun into the yarn that eventually becomes the clothes we wear.
Now, here's a crucial step that you probably never hear about: winding. So you see, the yarn is first made on these little bobbins. The problem is, they'd run out constantly. Winding is just the process of transferring all that yarn onto these huge cones. Why? It makes the whole manufacturing process way more efficient. You avoid stopping the machines all the time to change out a tiny bobbin.
And this just shows you the incredible scale we're talking about today. What you're looking at is the Saurer Autocoro 11. It's the world's longest rotor spinning machine. Basically, it uses a super fast spinning rotor to twist those fibers into yarn at mind-boggling speeds. And get this, a Turkish company called Biska Textile has 18 of these monsters, and each one has 816 spinning positions. Just think about that. They're churning out massive amounts of high-quality, sustainable yarn from recycled fibers.
Okay, so we've got our yarn on these gigantic cones. What's next? Well, now we have to get it ready for the loom. And that means setting up thousands and thousands of threads in perfect, parallel order.
If you were to open up a textile textbook, you'd see a diagram that looks a lot like this. It's the basic idea of warping. You take the yarn from a big rack, which is called a creel, and you wind it onto a huge cylinder called a weaver's beam. Seems pretty straightforward, right?
Well, this is what that simple little diagram looks like in the real world. It is a colossal wall of yarn. We're talking thousands of individual threads all being fed at the exact same time with incredibly precise tension control. It's just a stunning feat of mechanical organization. But before any of those threads can actually be woven, they go through a process called sizing. The best way to think about it is like applying hairspray to every single thread. This coating makes them stronger, smoother, and way less fuzzy, and that's absolutely crucial for them to survive the intense friction and tension of a modern high-speed loom.
All right, now we get to the magic moment, the point of creation, where all those individual threads finally become fabric.
You know, the basic idea of weaving hasn't changed in thousands of years. You're just interlacing two sets of threads, the lengthwise ones, called the warp, and the crosswise ones, the weft. But the technology that actually does this today, that has been completely, totally revolutionized.
I mean, today's factories are just pushing the boundaries of what's possible. You've got technology like Shima Seiki's whole garment, which can knit an entire sweater in one single piece, no seams at all. Then there are electronic jacquard looms that can weave patterns with just breathtaking complexity. And maybe the biggest deal of all, the design process itself is going digital.
And this is where virtual sampling is a total game changer. Instead of making physical samples over and over, designers can use software like Apex Fizz to create these incredibly realistic digital prototypes. Just think about it. That means no wasted material, no shipping samples back and forth across the world, and a design process that's suddenly way faster. It's a huge leap forward for both efficiency and sustainability.
But here's the thing. As impressive as all this physical machinery is, and it is very impressive, it's not even the biggest revolution happening in textiles right now.
Yeah, it's easy to get wowed by the giant spinning frames and the super fast looms. But the real game changer, it's something you can't even see.
It's the data that connects them all. It's the software, the AI, and that constant stream of information that turns a room full of machines into a truly smart factory.
Take platforms like SmartX Core. They use machine vision and AI to basically act as a digital supervisor, watching every single inch of fabric as it's made.
These systems can spot tiny defects that a human eye would totally miss. They can analyze how well the machines are running, and they give factory managers this live dashboard of the whole operation. The result? Way less waste and a level of quality control that was just impossible before. Okay, we're at the final step in our journey, finishing. This is where the raw fabric gets treated to give it its final look, feel, and all its performance qualities. And you guessed it, this part of the process is also getting a huge, smart, green makeover.
What you're looking at here is a Bruckner Stenter. You can think of it as a giant, incredibly high-tech oven for drying and heat-setting fabric. But the key here is that it's engineered from the ground up for maximum efficiency. It's got things like perfectly uniform airflow and heat recovery systems that are all designed to slash its carbon footprint.
And the future looks even greener. I mean, we're talking about companies developing burners that can run on hydrogen instead of fossil fuels. They're using AI simulation tools that can figure out the most energy-efficient settings before a single yard of fabric even enters the machine. And of course, there's digital monitoring to make sure every single piece of equipment is running at its absolute peak performance.
So there you have it, from a discarded plastic bottle all the way to an AI-monitored, sustainably finished smart fabric. The journey our clothes take is more complex and, honestly, more fascinating than it's ever been. It really just leaves you wondering, as our clothes become these amazing products of AI and recycling, what are we going to demand from them next?